I get the icon in cornflower blue?
Hey everybody, welcome to episode 8 of Can I Get That Software in Blue? I'm one of your hosts, Chad Tindel, and along with me is my esteemed co-host, Steve Mayzak.
Hey everybody.
Great news, Steve. We had a big milestone this last week. We passed the 1,000 cumulative listen view mark.
Oh, nice.
Yeah.
1,000 listens.
Yeah, we've got over 1,000 listens or views because people watch on YouTube too. So that's great. And if you could help us, please help us get the word out, not just by sharing on LinkedIn and Twitter, but if you can also leave us a rating or a review on Apple Podcasts, that does help more people find our podcast. We want to reach as many sales and pre-sales people as we can, so we appreciate the help. We're excited to be joined today by Timo Jokiaho, Red Hat's Global Chief Technologist for the Telco ecosystem. And it's our second international episode with Timo joining us today from Finland. So it's Friday night in Finland. We're happy he's given us some time. He's at Red Hat, very focused on 5G technology using containers and network function virtualization, which is kind of where you take components like routers, firewalls, load balancers, and run them as software-based virtual machines on commodity hardware instead of using more expensive proprietary components. He also has a special focus on disaggregated radio access networks, which he recently published a blog post about, and we'll be talking about more later. Timo, welcome to the show. I have a fun thing to share with you. Hold on, let me share my screen really quick.
Oh, wow.
Timo,
wow.
This is a fun picture. This is old when Timo and I were much, much younger. We sat together on a standards body called the Service Availability Forum. I don't know, must have been more than 15 years ago, and you can see how baby face and fresh we looked here if you're watching the YouTube video. This was in Tokyo, and
Wow.
I had this on my Flickr page, which I haven't uploaded photos to in many years, but it's still there. And the title of it was, "This is the fun table at the after hours party."
Is that a flip phone on the table?
Absolutely.
That's a flip phone. That's funny.
This was pre-iPhone, pre-smartphone days. So Timo was working at Nokia Siemens Networks. I was working at HP.
Nice. I actually remember. I remember this.
Okay, so Timo, on a previous episode, we actually had Adrian Havel, and he threw out just a tidbit. It wasn't a telco-related episode, but he threw out this tidbit about 5G and how it would be better in really closed quarters like a stadium where there's thousands and thousands of people around. He was saying the 5G access would be better, and he just kind of threw out that tidbit. And I had a few people reach out to us and say, oh, that was actually really interesting. I didn't know that 5G would solve that problem. If you guys could do a show that covered telco stuff and 5G, that would be awesome because I think a lot of people would be interested into it. So that's why, I reached out to you. And so today I think we want to start by talking about 5G as you're a telco expert, what it means for users, what kind of bandwidth people should expect, the ability to function in crowded environments. Can you just give us like a quick overview of 5G, what 5G is, and how it's going to change our lives for the better?
Yes, sure. I can do that. But of course, it's a really, really wide topic. I mean, fantastically wide topic. And, if I start with this, what you just mentioned, this stadium thing, 5G alone does not really solve that problem. But you have to combine 5G with the edge computing. And once you have that, then you can solve these dense population places like stadiums on all these things. But edge is kind of considered to be part of 5G, but it's still its own concept connected with 5G.
And what is it? What is it about 5G in particular that would make stadium access better?
Well, of course, the lower latencies between the mobile device or end device and the edge data center or the home network, the latency, which is going down, hopefully dramatically compared to the previous generations. Now, there's, of course, a big discussion. Do we really need 5G? Why not 4G is enough? Do we really need 5G? But it's I find it kind of funny because industry had exactly the same discussion when 3G was introduced. Hey, we have 2G, it's cool, coverage is good, everything is nice. Why do we need 3G? And then the same discussion when 4G was 10 years later was introduced, and now the same thing. And of course, it's a good question. Why is this happening? But my take on this whole thing is that I'm not too much focusing on business benefits and business cases and killer applications, what people are talking about. to me, this is just a natural evolution of the technology, which is inevitable, and it has to happen because what the humankind or world is looking is continuous progress on all fronts, technology included. So this is just a natural thing to happen, and people will find their business there. They will find how to monetize this. There is no doubt. So that's my take from the simple take on 5G. Now, 5G is, of course, it's a big thing. It's not just a mobile network. It's a kind of a converged mobile and fixed network on the network side. And on the mobile side, there will be new frequencies, higher frequencies, like beyond 40 gigahertz, which can give like 10 gigabit per second per user, mobile user. Do you need 10 gigabit to your mobile phone? I doubt, but technology allows that, and technology allows to drive that kind of bandwidth over the radio interface, which is fantastic.
I'd love 10 gigabits in my house, much less over my cell phone. That'd
Yeah,
be awesome.
I would use my phone as my access point.
Absolutely.
Exactly. So that's a good point, because fixed wireless access, as people call it, so you will have a 5G modem, installed into your house, and you will get over the air. You can get, gigabit speeds to your house. So you don't need to lay fiber or anything else anymore. For higher speeds, lower latencies, and combining these two things, you can tackle these stadium kind of use cases. Then add a third component, which is a ultra reliable communication. So reaching a kind of a similar kind of reliability over the air, which you can reach over the wire. That's one of the benefits of 5G. So combining all these things, there will be tons of use cases people will figure out.
Timo, it's interesting. Like, we have 5G down in Phoenix now where I live.
Okay.
And I see my phone switch to it more and more often these days. But when it first rolled out, it was much slower than the 4G. I was always trying to find ways to get it, go back to the old LTE stuff. Why is that? Is it just that like there's a mismatch between rolling out the towers and the edge computing that's needed to process everything?
Yeah, so I have exactly the same thing, by the way, here.
Okay.
So I'm living about 15 kilometers north from Helsinki downtown. Helsinki downtown, it's all good and fantastic. But here,
Okay.
I have the same. And that's why I keep my phone on 4G by default, because of that reason. There are several reasons why that happens. And in my case, I don't know about Phoenix, but in my case, the reason is that the local operator is using the same lower frequencies for 5G as they are using for 4G and 3G. And lower the frequency, the slower the speed.
Yeah, so there was a study that was done that I found here in the United States, kind of comparing Verizon to AT&T to T-Mobile and seeing which network was the fastest as far as 5G so far. And T-Mobile has won this shootout twice, actually. And Verizon comes in last place, surprisingly. T-Mobile's pushing roughly 58.1 megabits per second, and Verizon's down at 47.5 megabits per second. So that's pretty far away from the gigabit speed that you were talking about, or the 10 gigabit speed. And that's just what? That's just because they haven't rolled out the new frequencies yet?
Well, frequency is probably the main contributor to these numbers, because they look like a like 1800 megahertz kind of frequencies.
So is that just because the government hasn't allowed them to use those frequencies yet, or they just haven't started using them yet?
They haven't started, so it's very, very expensive and laborious to build up new towers, because towers need to be there need to be a lot more towers, because the distances between the mobile device and the antenna is way smaller when you go to a higher frequencies.
So Timo, if I'm understanding this correctly, as we go through the generations of cellular technology, radio technology, if we keep using the same radio technology, does that mean that when we get to 6G, 7G, 8G, that there's going to be even more towers around because it just gets shorter and shorter, the distance?
Yeah, so if we only talk about the frequencies, and the higher the frequency you go, the shorter the distance is. So it has been estimated that if all the frequencies which are now specified for 5G, up to 46 gigahertz per second, gigahertz, which is very, very high frequency. the number of towers can be tenfold, so 10 times
Wow.
numbers. Yeah. And if we just quickly touch 6G, people are talking about terahertz frequencies.
I mean, I just did the math. That's one tower for every 62 people, just using a billion people as the
Yeah.
line.
So do you think 5G is really the end of the road here in terms of what everyone will have access to, and 6G will just be highly specialized for certain places?
I don't think so, because one of the big things in 6G, which is already under research right now, and maybe even 5G will have it, is to start using satellites for the communication in addition to the landline.
Is satellite technology the same? Is it using the radio frequencies? It's just that the base station's now in space, and so you just naturally get more
It
coverage.
is.
Okay.
Yeah, it is. It is. And since they are quite far away, the frequencies cannot be too high.
Who is it that decides what goes into 5G, what goes into 6G, like what the definition of 5G and 6G actually are? Is there a standards body that makes that
Yes.
decision?
Yes. So that's a good point. Now, if we start from the beginning, which is 2G, of course, there was 1G, which was analog technology. The US, Japan, Nordic countries had. But 2G, which was originally called GSM, that was specified by ETSI, standardization organization called ETSI. It's a European Telecommunication Standards Institute, although it's a global, although the name implies European, but it's global. Starting from 3G, there's another organization called 3GPP, which is a standardization authority for 3G, 4G, 5G, and going forward. So they do have their own standard release schedule. I think we are going somewhere release 18, which is introducing a lot of 5G things. Release 19, 20 are starting to introduce 6G features into the standard.
We had some questions, Timo, about things like self-driving cars, where, I have sold to before. I had a meeting out there. They told me when I was out there that each car that they were testing for self-driving was putting out like 2 terabytes per hour of data, and that's all over the wireless network. So I'm just curious, with all of the electric cars coming to market, self-driving become a bigger thing, how long until 5G gets clogged and then we have no choice but to go to 6G?
From the connectivity point of view, I think with 5G we can go quite a long way.
The other thing I was thinking about earlier was about governmental regulations in 5G and how those either help or hurt the rollout of new technologies like 5G. So I was just curious, from your perspective, you probably have been in a lot of countries to see how this works. Like, who's the best at rolling out new communications technologies from a governmental perspective, and who's the worst?
But there are a couple of countries which seem to be always the first. South Korea is always. It's kind of a test lab. They have advanced vendors and they have advanced operators, and they are always the first.
Okay.
China is the other one. With the similar reasons, they have vendors and they have operators, advanced operators.
Timo, how do cloud providers play into all of this? And I ask because in the old days, when I was in the telco world, there, just so people understand what the structure used to be, there was these three tiers, and you had equipment manufacturers, let's say like HP and IBM, and they made very specialized, hardened, carrier grade telco computers, servers, and then you had network equipment providers who would buy those servers, people like Motorola, Ericsson, Nokia, Siemens Networks, and others, and they would package their own proprietary software on top, software that's made for carrier grade type systems, and then they would sell those to service providers and people like Verizon and AT&T, et cetera. And those were kind of the three tiers. But as more stuff has been commoditized, and I assume just moved off of this specialized carrier grade hardware, and more stuff maybe moving to the cloud. So how do the cloud providers fit into all of this?
Now, that's of course fundamentally important question. Now we need to go back maybe 7-8 years ago when about 15 service providers, they wrote the initial white paper called Network Function Virtualization, NFV. The idea was to break that vertically integrated model, to have a specialized hardware and tightly integrate the software stack, proprietary software stack in one box. And the box, of course, external interfaces of the box, it had to comply to this 3GPP standard specification. That was the model. Now, that model wanted to be broken, and it has been broken by first introducing virtualization on high volume servers and switches and storage from HP, Dell, Lenovo. Virtualization in form of maybe OpenStack or VMware or whatever you might have, and then convert the network functions into virtualized appliances in virtual machines. So that's been happening now for quite a few years and successfully in most cases. And now the containers are chiming in, and there is a movement or transformation from virtualization to containers on bare metal right now going on. And now when that happens or has happened, that actually brings the hyperscalers in for the first time seriously into telco networking, because
And when you say hyperscalers, you're talking about AWS, Azure, GCP, etc. Okay.
yeah, so Google, Microsoft, and Amazon. So 3 hyperscalers, and then smaller ones, Alibaba's, and you name it. So they have now a good chance to host the network functions which have been virtualized or containerized on their own stack, on either on public cloud, I mean real public cloud on data center, or use hyperscaler stacks on premises at the telco provider and host these network functions. And if you take a look at public cases like the Greenfield Dish network in US, which is using AWS as a software stack to host network functions and building Greenfield mobile network. Hyperscalers are quite active, even aggressive, to provide edge computing facilities and opportunities to the service providers.
Yeah, I saw this article came out literally just like 2 or 3 days ago. Verizon debuts private mobile edge cloud computing for enterprises with Azure. And I know you mentioned an AWS customer. I want people to know that I work for AWS, but we're here to talk about the whole industry. This isn't an Amazon show. So yeah, Azure does win some of these, and they are obviously going to market with Verizon. So, I noticed that in the last year or two, Red Hat's advertising push has been less about containers now, which it was for a long time, and more about edge computing. And you've mentioned it a few times now. Can you really tell us what does that really mean? Why is Red Hat pushing into that space so hard? And how does it apply here in the 5G space?
So we are very active on edge computing, like everybody else in this industry, and we are pushing containers to the edge. I mean, as a software stack, containers to the edge, hosting the edge use cases or edge applications, whatever those might be. And just to note that we at Red Hat, we don't have any applications to any purposes, not edge, not core. We always need our partners to build the end use case with their applications. We just provide the open source platform. Used to be more virtualization platform in form of OpenStack. Now moving more and more to Kubernetes container platform and pushing that to the edge. But
what does the edge actually mean? Is it like it's in Verizon's data center, or it's at Verizon's? It's like literally at the edge where like the cell tower that my phone is talking to. Is that the edge?
So let's talk about cell towers and edge in a minute. But what's happening right now in Verizon's case and many other people's case is that they have identified in their country, US, or let's say Deutsche Telekom in Germany and other people, they have identified physical locations where the traffic volume is higher and more demanding than generally speaking in their network. So they start to locate those edge data centers in those places, which are then closer to the users in that space for whatever the use case might be or the application might be, which they then locate into these edge data centers. So there will be spots in the country from geographic point of view that there is a edge data center here, there's edge data center here, and so forth. So edge is not very easy to kind of identify what edge means, but that's one characterization that they identify high traffic locations and place edge data centers in those places. And closer to the real edge you go, I mean, the further and further towards the edge, which soon brings me to the disaggregated radio access network, which is one edge use case. Maybe not the sexiest one, but it is a use case, a real use case. Then the compute resources and footprint resources are very strict. Squeeze your edge data center and your platform and your applications in smaller and smaller boxes, less and less compute power, memory, all these things.
So you mentioned containers. Is that one of the reasons why containers are, and maybe because containers are more efficient, that's why they're moving towards the edge? Are people actually running Kubernetes in these edge data centers? Is that kind of the underlying infrastructure?
Yeah, so Kubernetes is, of course, a big thing. And what we are pushing and many other people are pushing is to have a consistent Kubernetes-based container platform all over the places. Starting from IT data centers, going to mobile core network, going to radio access network and edge, to have the same Kubernetes container concept in all of the places so that you can onboard your application in any of those locations when you and even move your application from place to place when there's a need for that, with automation, hopefully, or preferably.
Yeah, I assume it's still evolving. I mean, I saw that AWS has this Wavelength service, and yeah, I think it's actually taking Amazon hardware and putting it into service providers, if I understand it correctly. I know nothing about it, but that way you can run your app directly inside of Verizon's data center, as opposed to it needing to traverse the internet to go from Verizon into AWS's cloud.
Yeah, so that's what I try to, being a hardcore telco guy, I always try to explain that when you use the hyperscaler stack, AWS, for example, you can use it in AWS data center, wherever that might be, some random data center, as I say, or you can use AWS stack on your own premises, but still have the same stack all over the places. And that's what we do with our container platform, trying to kind of harmonize and get consistent execution environment for applications in containers all over the places.
So we mentioned this in the intro that you wrote this blog post about open radio access networks and disaggregated radio access networks. Can you just kind of tell us what this is all about?
I wrote this on one specific purpose. It hopefully gives an idea what this disaggregated base station is. Like this diagram right here, vertically integrated base station, the antenna side is now splitted into different entities. And some of the entities can be cloudified using cloud platforms and can be located away from the antenna side to save or to make antenna side easier, simpler, and be less power consuming and all these things. So splitting the functionality into different entities, which is called split baseband, disaggregated RAN. Disaggregated RAN, which these diagrams show, there are now three entities. There is a radio unit which is on top of the mast, and that never goes away. That's the left-hand side on all of these diagrams. The disaggregated part, the distributed unit in the middle, and the centralized unit on the right-hand side, those are now taken away from antenna side to make the antenna side simpler. And those are the software entities, very challenging software entities from real-time execution point of view and timing and synchronization point of view, and still need some hardware acceleration. But those are now running on cloud platform. It can be virtualization platform or container platform.
Is the concept that we used to have of like carrier grade hardware, ATCA hardware, all those special blades and everything, is that just gone and everything's all on regular servers?
The specialized hardware is gone maybe 95% of the cases. But again, in this diagram, the radio unit, which I have attached the antenna to, that is still proprietary hardware, specialized, highly specialized, very, very price and cost sensitive hardware. But the rest, the other two, centralized unit and distributed unit, standard servers.
Timo, I was wondering, I found an article when I was doing research for the podcast about the 90-day program in Helsinki, where apparently there's a mass exodus of people moving to Helsinki from all over the world, the US included. And I was surprised to hear that like Helsinki is really embracing this, and they created a program called the 90-Day Fin campaign. Do you see, like, is there evidence, visual evidence, or, in your network, are you seeing an influx of people and talent coming to Finland and Helsinki and specifically?
No, it's not kind of generally seen very widely, but it happens. It happens, for example, in high-tech industry, or specifically in high-tech industry and telecom industry. That happens, and it has been very successful. And obviously, there's a reason why this is done, because we are actually losing quite a lot of people abroad from this small country. In our universities, which are free for everybody, even foreigners. The problem is that people come here, they study, they do their degree here, and then they go away. That's not a very good model. And that's why, for example, this program has been invented to get people in. We need more people in this country. So Finland is, after Japan, Finland is the most aging country in the world.
Oh, is it really?
Yeah, Japan is by far the first,
Yeah,
aging, and Finland is the second, which is a problem.
It seems like every generation of phone, the battery life gets a little worse, and then we get better battery technology, and then it just kind of rinse and repeat. Is it the same thing going to happen for 5G?
It is. And, that comes back to higher frequencies, higher speeds kind of thing. And that just drains battery. And that's the other reason I keep my phone still on 4G by default, just to save battery. And I switch 5G on when I do the measurements, or I do have some reason to. It's a hard problem. And what mobile industry, or the handset industry, mobile device industry, is kind of relying quite a bit on electric cars and how the battery technology develops based on the electric cars, which then can be reapplied to mobile devices eventually to have longer lasting batteries.
Yeah, that's a great point. Are there any cellular networks or parts of the cellular networks that are powered by solar?
Oh yeah, in many countries, if you go, for example, Middle East, where there is pretty much sun all the time, many of the cell sites are solar powered. They have panels, and they do that.
One of the topics that we seem to talk about here a lot is blockchain, cryptocurrency, stuff like that. Is there any future thing where blockchain is going to play a part in the telco network or the telco space?
I'm sure there will be some use case for blockchain technology. But what is now looked into quite actively is using quantum key distribution technologies to have a more secure communication, which in theory cannot be kind of broken.
Oh, that's fascinating. That's a whole nother topic we could talk about for a long time, I'm sure.
Wasn't there someone recently where the law enforcement created their own phone and convinced drug dealers that it was a secure phone?
Yeah.
So they all started using it, and they didn't realize law enforcement could see everything they were doing?
Exactly.
All right, should we bring this balloon back down to the ground, Steve?
I think we should, yeah.
All right. Timo, thanks for joining us today. There's been a great conversation about 5G and telco architecture. I think you're going to go earn your PhD in quantum computing and come back to us, and we'll have you on a follow-up episode all about quantum computers and the internet. We want to thank everybody for listening, and please share us if you can. Again, we are available on Spotify, Apple Podcasts, Stitcher, and wherever else you get your podcasts. So thank you for listening, and we'll see you all in the next episode. And thanks, Timo, again for joining.
Pleasure.
Thank you.